I'm going to show you how to solve your circle theorems, how to even recognize the particular theorem to apply for any given question under circle theorem. Welcome back to my channel. So there are several circle theorems, all right? But this particular time, I'm going to be giving you hints on how to know the particular one to apply in a particular video, all right? Or in a particular question, rather. Now, if you look at this, first of all, you are seeing this. This is coming from the center and then touching the, just like this triangle you are seeing inside. This is giving you a hint that you are going to make use of this particular circle theorem that states that angle at the center, the angle that an arc subtends at the center is 2 times the angle it subtends at the circumference. What this means is, assuming what we have here is 120 degrees, what we are going to have here is 120 divided by 2, which is 60 degrees. That is one that I'm already seeing. I've not even started applying it, but I'm already seeing that with the knowledge of this, I'll be able to get to my destination. All right. Another particular theorem I'm seeing here is this. I'm seeing a tangent and I'm seeing a radius coming from the center of the circle. I'm seeing a tangent. A tangent is a straight line that touches a circle at just one point, right? So if I call this point A, point B, point C, point D, all right? AB and AC are tangents to the circle at point B and C, right? And I have a radius coming from the center to touch the tangent at its point of contact with the circle. That is telling me another particular theorem that states that in a circle, okay, if there is a tangent AB, and this is the center of the circle, while this, let's call this P, point of contact between the tangent and the circle. If you draw your radius from the center to touch this particular tangent at its point of contact with the circle, then 90 degrees is formed, right? And 90 degrees is formed between the radius and what? The tangent. So these are the theorems I'm already seeing and I've not started applying them anyways. Now let's get to work. Okay, first, if this is the first time you're seeing this channel, please don't forget to click the subscription button and turn on your notification bell. That way, if I post any video, you will be notified. If you don't subscribe, maybe this will be the last time you're going to see this channel. So if you actually value whatever you are seeing here, you need to subscribe right now so that you don't forget. So we're going straight to solve this. Now the question said we should find the value of m, right? So first of all, using the particular theorem that I just said, that angle between a tangent and a radius at its point of contact is 90 degrees. That simply means that angle C will be equal to angle B, which is equal to 90 degrees, okay? That is, angle C here will be equal to angle B here. Both of them will be 90 degrees. All right. Now, if we actually look at this, you now see that we have 90 degrees, 90 degrees, we have 40 degrees. So we can easily find angle at the center, right? How can we do that? First things first is that angle is that ABOC. ABOC is a quadrilateral, right? ABOC is a quadrilateral. All right, so ABOC is a quadrilateral, and the sum of angle in a quadrilateral is 360 degrees, right? So it means that angle BOC, obtuse angle BOC, will be equal to 360 minus, then we have 40 plus 90 plus 90. So we are going to have 360 minus 40 plus 180, right? 360 minus, this should be 220. Now 360 minus 220 is going to give us 140, right? So it simply means that the obtuse angle BOC is 140 degrees. Amazing, right? Now let us apply the second theorem. The second theorem that we talked about, the one we said that angle at the center is 2 times angle at the circumference, right? So this theorem that states that the angle formed by an arc at the center is 2 times that which it forms at the circumference. So if this is 100, like I said, this is going to be half of 100, which is 50. Therefore, if this is 140 degrees, then this place, let's call it D, angle D will be equal to 140 divided by 2, which is 70 degrees. So here is 70 degrees. All right. If we look at this from here, all right, to here is what? 180 degrees. Is 180 degrees, that is angle on a straight line. So if I should call this particular angle here, let's call it A, all right, A degrees. Now to get A degrees, we are going to have 180 minus 90 plus 65. So you have 180 minus, this is 155. And this will give us 25 degrees, okay? So it means that this place is 25 degrees. Hope you are seeing how this works, right? How this is going. Now we are asked to find M. Let us find reflex angle BOC. Okay? To find reflex angle BOC, angle at the center is 360 degrees. So reflex angle BOC will be 360 degrees, take away 140 degrees. Okay? 360 degrees, take away 140 degrees. And that will be 220 degrees. So this place is 220 degrees. Now, I want you to note that BOCD is a quadrilateral, even though it looks like a triangle, but actually a triangle has 3 sides. But if you look closely, you see that that has 4 sides. We have this, we have this, we have this, we have that. Okay, so this is B, this is O, this is C, and this is D. 1, 2, 3, 4. So this is actually a quadrilateral. And the interior angle of a quadrilateral is 360 degrees. 360 degrees. Therefore, to get angle M, will be equal to 360, take away 220 plus 25 plus 70. So our M will be 360, take away 25 plus 75 is 95, plus 220 is 315, right? And this will give us 55 or 45 degrees rather. So it means that M is 45 degrees. Thank you for watching and see you in my next video. Bye.